Hello everybody and welcome to my presentation about a German standard under development, the DIN SPEC 91607, Digital Twins for German cities and communities, a standard for municipalities to set up urban digital twins. The DIN SPEC, by the way, is the German equivalent of the British PASS standards. It's a simplified, lightweight procedure to create a standard specification. My name is Ulrich Hartmann. I'm a product manager at Oracle Construction and Engineering based in Munich, Germany, responsible for BIM, the Econix CDE, and more for digital twin stuff. And I'm also very active in standardization at ISO, CEN, and German national standardization institutions. Also crazy enough to write a very comprehensive book about BIM, the BIM standards, and the practical application of BIM in a tiny 600 pager, all German, sorry for that. So anyone who reads German, please have a look. Before I dive into more detail about the DIN spec of digital twins for German cities and communities, let's have a look at the current situation. Public administration in Germany and in the entire EU is required by laws and regulations to provide online access to general public services such as administrative activities like getting new license plates for your car, application for building permits, looking up GIS, city information or sustainability information, early warning information about incidents and environmental risks like floodings, heat, etc. All this should be available online, and processes around this should be, or at least become, digital in the very close future. So, where are we today? What are the pain points? We have a slow approval process for building permits, which is a major blocker in the meeting of a demand for new housing. We have text-based regulations, not machine-readable, for building design that impede a consistent model-based way of working with BIM. In urban planning, the effects of new buildings on the building stock must be taken into account so that acceptance problems can be avoided from the outset, for example, by citizen involvement and participation. And in times of climate change, material damage and loss of life from floodings caused by unforeseen heavy rain events, etc., require protective measures. And finally, we need a comprehensive understanding of the energetic reality of supplies and consumption to implement energetic renovation measures. However, information about all this is scattered across several sources and stored in the information silos of the different agencies and authorities on different federal levels. So what is the digital maturity of German public administration? In general, there's much space for improvement, of course, but there's also a huge disparity top-down on the national levels, but also between authorities on the different federal state levels. There are many good examples, like the city of Munich or Hamburg, rich cities with already existing digital solutions. They are the driving forces in Germany. Let's take, for example, Hamburg. They show significant thought leadership and already have practical experience of over a decade, maybe the best equipped administration in Germany. They started off with the implementation of an e-governance portal some 10 plus years ago. Hamburg is one of the initiators and drivers on federal state level in Germany. For example, spearheading the development of exchange formats for urban planning and building permits, and helping also other cities like Cologne and Frankfurt in strategic partnerships. What we see here is one service of the GeoPortal Hamburg, showing the load stations for electric cars. This is the front end of a web service that can be used by other third-party applications. They can get all the status information and metadata about any charging station in the city. Applications can subscribe to this real-time information system via REST interfaces through web services. So this is just one example of many others available online here. What we see here is another example of the Urban Data Platform of Hamburg, the cockpit that shows how frequently services are being used over a time period. The data provided can be used by third-party applications and other services to generate added value. There's a smart system architecture in the back, of course, and this cloud-based e-governance platform has developed over decades in the past. So this is Hamburg, and how can we make it a success story for other cities and communities in Germany? We don't want to have a patchwork of incompatible solutions across the country. How can knowledge and best practices be shared so that other cities and communities can build upon this? This is why the German national standardization body, the DIN, initiated the German Smart City Standards Forum to create a common platform for discussion and development, and a whole row of smart city standards have been developed so far. This started off in 2017 with a DIN-SPEC standard about a reference architecture for open urban platforms. Then we've seen the lampposts could be stuffed with IoT sensory equipment to send traffic data, environmental data, and so on, published in 2018, the DIN-SPEC 91347 about intelligent street lighting, integrated multifunctional humble lamppost, and the next in the row of smart city standards, urban mobility data collection for real-time applications in 2019, and the year after, the DIN-SPEC 91387 about municipalities and digital transformation. An overview of the fields of action was published. Fields of action meaning for smart cities things like digital administration, digital infrastructure, mobility, energy, environment, health, and so on. A first general view on the agenda for cities and communities on digital transformation. Last in this row of publications, and by the way, all publicly available as free downloads under this link I'm showing here. Last in this row of smart city DIN-SPECs is the guideline for the implementation of digital systems for neighborhood or city quarters management. So after all this pre-work, how do we put all these best practices, knowledge, experience, etc. together? Is there a common integration denominator? And this question was the sparking idea for the DIN-SPEC 91607, Digital Twins for Cities and Communities. Kickoff was in May last year, and publication is planned for the next year. As you can see on the right, a whole lot of German cities are taking part in the development of this DIN-SPEC. Some of the bigger ones like Hamburg, Berlin, Munich, and also mid-size and even smaller ones are taking part. And what are cities and communities aiming for? So the first question we asked was, what are your most important use cases, having the core fields of action in mind? As mentioned before, 98 use cases have been sent in by those cities. Main areas were urban activities like traffic management, urban development, citizen involvement, e.g. in urban planning, planning management of the utility infrastructure, e-governance, and the management of city property and real estate, project control via BIM. A first indication that digital twins and BIM may have a strong connection. And then, of course, unsurprisingly, several sustainability topics and also disaster prevention use cases. So let's focus on what BIM can do. In other words, the question is, can digital twins learn from BIM information management? To recap about BIM, BIM is pull, not push. Don't wait for information to come. Express your information needs explicitly. There are no usual deliveries of information without any expressly specified need. Information needs arise on different levels. On the organizational level, information to achieve overarching strategic goals of a company, authority, or institution. In this case of urban digital twins, it might be overall regulations for building permits, urban planning, etc. On the level of projects, information to run the digital twin project, for example, to simulate the effects of construction work on traffic in the city. And on the level of assets, and the asset is the city or parts of it in this case, it's the need of business, commercial, and technical information for smart city operation is inferred from this level. And in parallel to BIM, a structure for data integration must be set up, the equivalent of the BIM asset information model, for example. And last but not least, you need a platform to physically keep all the information together, a platform to deliver information to, like the CDE, the Common Data Environment in the BIM case. Of course, our task is nothing less than saving the world. So the construction sector accounts for 30% of all greenhouse gas emissions worldwide, 40% of energy consumption, 50% of resource consumption, and 60% of waste generation, and even 70% of sealing the natural ground. So BIM projects can be a significant provider of information around all this. BIM information must be delivered into urban digital twins. Information requirements according core use cases must therefore be specified. How can we put heterogeneous information resources together in an urban digital twin, for example, for analysis? How could this be made? In the DINSPEC team, we were looking for concepts for the integration of data on a higher level. So, of course, we ended up with a DIKW pyramid, a semantic web concept representing structural and/or functional relationships between data, information, knowledge, and wisdom. Typically, information is defined in terms of data, knowledge in terms of information, and wisdom in terms of knowledge, so each building upon each other. And we adapted the pyramid a bit for our own purposes, with basic facts in the basic data sources at the bottom, selected, structured, and federated into structured data, which is then enriched and refined and put into the context to generate new information, which by conceptualization gives new insights and represents new knowledge, which then builds the basis for decision making and triggering actions in the city. Imagine a city wants to track city climate and air pollution. On city level, you have traffic databases, you have a sensor network for air quality, temperature, air pollution, etc., and you have access to meteorological data. And then one level up, you also have GIS data of the city infrastructure like roads, buildings, green area, waterways, etc., even 3D city models. All you need to do is to put all data together, for example, in a simulation scenario where you apply seasonal weather conditions or extreme weather events and see the effects in the city model. Looking at the hotspots and critical conditions, measures might be developed, analyzed, and taken. So far, so good, but there's one big devil in the detail. The different data sources reside in different databases owned by different stakeholders and in different formats. So it's not the lack of data in many cases, it is to overcome the integration hurdles, and that rings a bell, the BIM bell again. Digital twins can learn from BIM in terms of the production and provision of information. BIM information management concepts should be applied to digital twin information management. In this heterogeneous field of data, how can data be integrated at all? Like in BIM projects, digital twins need a project information strategy. There are so many types of information resources. SQL or relational databases can be merged into new table structures, of course, but that's fine, but not a general approach. Semantic models can be mapped and transformed into another semantic model or even back into relational database levels, also not a very general approach. So semantic web technologies and knowledge graphs came also into our mind and our view. They offer a high level approach using ontologies and are capable of integrating different types of data sources. Technologies and products like Neo4j or TripleStore knowledge graph databases have been around for years, so they could provide a very flexible approach to the integration of information into an urban digital twin in a very general way. This could be a way to overcome the boundaries of those structural silos of different formats and technologies. So what can we draw as a conclusion from all of this? Urban digital twin development can leverage from BIM concepts. Semantic web technologies can help overcome structural silos. And the DIN-SPEC 91607 helps to integrate information resources for urban digital twins and might help overcoming structural silos. Thanks for having me and thank you for your interest. I'm keen on the following, hopefully vivid discussion.